All right, exciting. We are ready for lesson 3 of the chemical bonding storyline. What is a storyline? It's a sequence of lessons that, like a red thread, nicely flow into one another. Again, the official title of this chemical bonding storyline is Why Do Some Things Get Colder or Hotter When They React? For lesson 3 of the chemical bonding storyline, titled Why is the Thermal Energy Decreasing When Potassium Chloride Dissolves in Water, we are following a I do, we do, you do format of explicit instruction to really help students understand the solvation process at the particle level. How long did lesson 3 take me? Well, exactly 2 class periods. My periods are roughly 50 minutes each, but I spread those 2 periods over a period of 3 weeks because I was very busy during this time teaching everything to do with the periodic table trends. Check the link above for the updated lesson related to periodic table trends. When did I teach lesson 3? During quarter 1 of the school year. Again, we are now on the 3rd lesson of the chemical bonding storyline, but a few of these images really I dealt with during lesson 2 when students actually dissolve potassium chloride in water. I follow the I do, we do, you do approach. In the I do, I model the actual solvation reaction using these beautiful water and salt magnets from the company 3D Molecular Learning. Key to that modeling is that you start with reactants, with the bonds still connected. You break these bonds through the introduction of thermal energy, and you end up with a transition state. Hydrogen bonds are broken for water. Ionic bonds are broken for the salt particles. New bonds are formed, namely ion dipole forces, and those are the products of this solvation reaction. Since the ionic crystal lattice is broken, solvation in part is a chemical reaction. Check the links in the description below to see more details about why Linus Pauling calls this in part a chemical reaction. So upon completion of the I do modeling of solvation, students are ready for we do. I pair them up, they go and model the solvation process using both magnets and a whiteboard. Again, this was also part of the previous lesson 2. Now we're ready for the 3rd component of the I do, we do, you do. That would be the you do. The emphasis of lesson 3 is really for students to individually model the solvation process, and they do so in a digital manner. I'm focusing here on the Pear Deck icon. The Pear Deck icon enables me to share all the individual models of the students with the entire class. And then we can have a discussion about what we wish to keep for each of these models, what might be too redundant, what might be not detailed enough. And as we go from slide to slide, from model to model, you can see that the level of complexity is increasing. But clearly, thermal energy is required to disrupt the connection between the ions and the water particles. But the reason that I'm highlighting this 3rd set of models is because we see both a reactant component to the model, a transition component to the model where the bonds have now been broken as a result of thermal energy entering the reactants, and a product component of this model where new bonds have been formed. So upon completion of the analysis of all the different individual models, students are now ready to come up with important scientific terms that should be included in the model and the evidence that they must account for so that they can answer the key question. Is solvation considered a chemical process? And what is the thermal energy used for as salt is dissolving in water? And the key components that I want to highlight from this slide is that a model should include reactants that represent the start of the reaction, a transition that show that bonds have been broken, and your products that show that new bonds have been formed. And if you wish to see more details in terms of the evidence that the students had to account for, check the previous lesson number 2 where I go into that. That leaves us with the driving question board. This is key to keep bringing back because these questions develop over time. So here I'm showing you the question board after the first lesson. So this was back in September. And to really have my students think about these questions, I take them back out in my hallway where we have a bunch of whiteboards, and we simply hang up the existing driving question board questions. They try and answer them and possibly come up with new questions. And after that exercise, they were able to remove some of the questions, and I also gave them a chance to come up with new questions. Another group whiteboard session led to additional responses, which finally brought us to this month's driving question board as a result of having completed the first 3 bonding storyline lessons. And the one question that students are still struggling with the most is, why is the thermal energy going into the beaker not resulting in a temperature increase? Again, the various reactions that they've done so far were all endothermic. And that very question leads us to the next lesson in this storyline. Lesson 4, what makes atoms stick together? Stay tuned for that one. How can we best model bonds between atoms? But most excitingly, I am for lesson 5. Are magnets a good model for the connection between particles? Stay tuned for new and updated videos of my students' hands modeling the breaking of chemical bonds using magnets. The bonding storyline follows the next-gen science standards as well as the New York State Science Learning Standards, HSPS 1, matter and its interactions. And of course, energy is involved as well, energy change in components of a system. Storyline is een verhaallijn in Dutch. It's like a red thread, de rode draad, that connects all the different lessons to each other. Extremely powerful. If you wish to have these resources, they can be yours. Just check the link in the description below. In exchange for your email, you will get the following Google Doc with all my lesson resources. Many excellent lab handouts, including YouTube videos that explain how to do them with your students. And finally, if you are interested in my bonding kit, well, at the bottom of that very Google Doc, it tells you how to get all the different kit components from Amazon. Thank you very much for watching. Bedankt voor het kijken. Tot ziens, and see you in the next video.